Alrighty. Here we have Bohr's representation of an atom. Alright, that's called the planetary model. Here we have a carbon atom, which has 6 protons. That's how we know it's a carbon atom. Okay? In every atom, you have electrons, negatively charged, protons, positively charged, neutrons, neutral. Alright?
Okay, so now you're probably wondering about these subatomic particles, like how much do they weigh, stuff like that, some of the properties about them. And so that's what I'm going to show you now. So these subatomic particles, what we're going to do is we're going to use the measurement in AMU, which is atomic mass unit. That's how much they weigh. Now a proton is 1 AMU, a neutron is 1 AMU, and an electron is 1 over 1,840 AMU. Now an AMU, atomic mass unit, also called a Dalton, it's 1/12 times the mass of a free carbon-12 atom at rest at its ground state. That's the unit of measure that we'll use. And I'm going to show you, because you're like, what does that really mean? How much is that? You know, how much does that weigh? What it really means, like, converted to pounds. So, a proton would weigh 3.6602 times 10 to the negative 27. And this is kind of just a representation of what they would weigh. While an electron would weigh significantly less than that, 1.989 to the, times 10 to the negative 30. And so, yeah, that's how much they weigh.
Now, in this model, there's rings here, okay? Now, when Bohr made this model, he thought that this would show the radius of the atom. We now know this is not true. These rings also show the orbitals where the electrons travel. It's worth noting that this model is not accurate, and we only use this to teach younger students just so they can get a basic idea of what the atom would be like. Okay?
Okay, so now you're probably wondering more about the atom and how does it stay together? What is the glue that really holds this atom together? And so, as you know, like I said about the different subatomic particles, the protons, the electrons, and the neutrons, they all have an electric charge to them. And this electric charge creates electromagnetism. And as you might know or may not know, two alike charges repel while two different charges attract. So, two positive charges is going to, repel, and positive and negative is going to attract. And I'll show you that with the atom, helium again. And it kind of shows you how the atom is held together. So, as you can see, the positively charged nucleus in the middle attracts the cloud of electrons, the negatively charged electrons around it, and keeps that together. But if you think about it, well, all the protons are, they're all positive. So why are they sticking together? Why aren't they flinging themselves apart? Why does that make any sense? Well, there's a natural force called the stronger force. So the stronger force is a force that is stronger than electromagnetism, and it overpowers it. So when certain quarks are together, and quarks are what make up the subatomic particles, they're they're the smallest thing that man has ever seen or has ever found so far, and they make up the subatomic particles. And certain quarks are attracted to certain quarks, and that's what keeps those protons together. And it really works with those small distances. Let's see, if those protons were to get too far apart from each other, that stronger force would dissipate, and those protons would not stick together at all. But since they're so close together, that nucleus stays together, and the protons are attracted to the neutrons and all that stuff, and it just sticks together, and that's that glue that holds it together. Yeah.
Okay, so here we got my old pal Benjamin Franklin, old Benny. Now, Benny, he's noted for discovering that we have two charges, positive and negative, all right? And he did this through his glass rod experiment thing, okay? So Benjamin, he got 2 glass rods, and he was able to rub them with silk. And whenever he did this, he was removing electrons from the glass rod. And whenever he tried to put the glass rods together, they would repel each other. And then when he did this, he would do the same thing with rubber and fur, except this time he was adding electrons to the rubber. It would when he would put them together, they would go apart. Okay? And now if he took a glass rod rubbed with silk and a rubber rod rubbed with fur, when he would try and put them together, they would attract to each other. Okay? And we know this because opposites attract and likes repel. So that is how he discovered that we have two different charges, positive and negative. They also denoted this as the positive and this as the negative. Right? Okay. So this dude, my boy, Ernest Rutherford. Now this dude, is this focused? Bam. This dude, he is known for discovering the nucleus. All right, that's right, the nucleus. And he did this with his famous gold foil experiment. This would change maybe. Bam, gold foil experiment. Okay, in this gold foil experiment, he used alpha particles and gold foil. Now I used gold foil because you could smash gold foil into very, very thin pieces. Okay, so it made it easier. Now these alpha particles, positively charged particles, that were pretty much able to go through anything, right? Now what was expected was for these particles to be reflected or bend. But when they shot these alpha particles through this gold foil, most of them just went straight through it. However, few of them bounced off or bent, as you can see here. Now this told Rutherford, he concluded from this, that most of the mass and the positive charge of the atom were condensed in a very small and dense area, what he called the nucleus. Sir. Okay, here, got Robert Millikan, alright? He's a pretty good looking dude. I'm out of water, okay? AKA Homeboy Milkman. Let's go, alright? Now this dude, he discovered E, which is the charge of an electron, right? And he did this through his oil drop experiment, which you got here. Look, bam, on oil drop experiment, okay? First, you start out with the atomizer, okay? This atomizer produced oil droplets in the form of mist, okay? And these droplets fell and they hit here, okay? So they were sent through a plate of an electrical condenser, right? Several forces acted on them while they were falling, all right? It was gravitational force, electrostatic force, and vicious drag force, all right? Now as it fell, also came here with an X-ray. Now this X-ray ionized the air inside of the chamber, all right? Now, as these oil drops fell, they also gained a charge, all right? And old homeboy Milkman here could look at the rate at which the oil droplets fell through his microscope. Now, he could also change the rate at which they fell by changing the strength of applied voltage in the plates, all right? Now, through this experiment, he was able to develop the equation Q equals NE, which is the total charge, and then he also found E, which is 1.6 times 10 to the negative 19th C. All right? Homeboy Milkman. You know it.
So this is Charles Augustine de Coulomb, and he made Coulomb's law, and that really helped describe how like charges repel and opposite charges attract, and really how those nucleons in the nucleus stick together. And it really showed how the atom works, you know, that strong force that I talked about earlier. It really describes how all that works and really helps set up that atomic theory about, you know, about how the atom works. And yeah, so that's what this dude contributed.